Okay, so what we're doing is we're starting chapter 3. Chapter 3 has a lot of new information and it has just a lot of stuff to kind of understand and digest. So we're going to split it up into 4 different sets of notes. To do a lot of this stuff, we're going to use our intro survey results. You looked at these before, and each year I do them, so they might be different questions. And so just be aware that this might not be exactly the same results as yours. This is for the survey year of 2020 when we did this a couple weeks ago. Okay, so we have some different terms that we have to know. The first one is this quantitative data condition. This is similar to the categorical data condition, and it's just saying you must have quantitative data before you can do any of these charts. And remember, quantitative data is something that you measure and it has units. Okay. All right, so a histogram and relative frequency histogram. So we learned last chapter what it means to be relative. If something is relative, what it does is it changes it to percents. I am not going to do the table or a relative and a regular histogram, right? Because they're the exact same thing. They're just broken down on the axis with different numbers or counts versus percents. Okay, so some things about a histogram. We're going to write some information on the left, and then we're going to actually draw some. So a histogram looks like a bar chart, but a big difference is that they're connected. So remember on a bar chart, I said they can't be connected. And the reason they can't be connected is because histograms are connected. And so what happens is to do this, what we're going to do is we're going to start off by placing our numbers in bins. And hold on a second, my cat's trying to get out. And when you create bins, what you want is you want to have at least 5. If you have too many, you're not going to see some trends, but if you don't have enough, it's going to be hard to see also. And so we want to have at least 5 bins. And then what you want to do is you need to make sure you have a consistent label. Let's make sure I'm using the pencil. So you need consistent axes. So what that means is I cannot put a bin that counts as 5 and then a bin that counts as 4 and then a bin that counts as 8. Bins are where your tick marks are, how far apart your tick marks are. And so they have to be consistent. And then the last thing you have to do is you have to label. Gotta label your axes. Okay, so what we're going to do is we're going to make a histogram based on our initial survey results. So when I look at this, I can't do gender, I can't do political party because those are categorical. I have to pick a quantitative. So my quantitative ones I can choose are siblings, states, sports, height, shoe, and number of jobs. I think the one that's going to show the most interesting graph is states because it has the largest range. I think our minimum was 2 states all the way up to 50 states. Someone had been to 50 states, which is amazing. And so I'm going to show you how we kind of figure this out and what we do. But the first thing we're going to have to do is think about our bin size. If I do a bin size of 5, that would mean that I have 10 tick marks, which is a lot. I think I'm going to do a bin size of 10 so that way I have only 5 tick marks, which is a little better. Okay, so this is what my chart's going to start off by looking for. You might recognize that there is a 60 here and there's not 60 states, and I'll explain to you why we have that in a second. I always like to have one bin mark past where my max is, and you'll see why. Excuse me. Now, frequency. I went through and counted the state. I counted how many would fit in each bin, and the most number I have is 15. Okay, so I'm probably going to count by 2s. Let's see, 2, 4. You don't need to watch me do this. Okay, so here it is. One thing I want you to notice, do you see how my tick marks are kind of evenly spaced? And my tick marks down here are kind of evenly spaced. We need to make sure that you have them evenly spaced. Okay, so the first thing I do is we have to talk about what happens if somebody lands in 10. Now there's 2 train of thoughts here. You could put 10s in the bucket below or the bucket ahead, the bin above or the bin below. Majority of people are going to put it in the bin above. And so this bin right here, I'm not going to label it, but I'm going to kind of just draw it so you see What's in between right here is going to be the people that have been 0 to 9 states. And this bin right here is going to be the people between 10 and 19 states. Okay? Do not label your bins like this. You need to do tick marks like I've done here. But you need to recognize that what's in this first bin is people that have been to 0 through 9 states. Okay? So I'm going to erase those, and then I'm going to tell you how many have been in those bins. Okay, so here's kind of the summary of where people have been on our table. And so 0 to 9 has 9 people. So 9 people is going to be halfway here. I go all the way to my 10. And there's my first bin. There's my first bar of my histogram. 10 to 19 is the biggest one. It has 15, so I go straight up. And I go over and down. 20 to 29 only has 3, so I go here. And now you're going to see why I had to use an extra bin. 50 is the top number, and remember we always put that in the next bin. So 50 to 51, it goes just halfway, and it's right here. So that's our histogram. So again, you have to figure out what size bins you're going to have, and then you have to figure out the frequency in each bin. Okay, so later in the chapter, we're going to actually talk about how to describe this, because there's a pretty clear process you have to describe for histograms. But for right now, our goal of this video is just to learn how to make these different pieces of displays. So this is how you make a histogram. If you were going to do frequency, you would have had to find the percent and made this percents, and it would have worked out the same. Bars might have been looked a little higher or lower based on your scale, but then the breakdown in each bin is going to be the same. And then the next one we're going to do is a stem and leaf. A stem and leaf has been taught to you before. Whether you remember it or not, that's a different story, okay? So a stem and leaf, move my screen up. A stem and leaf, here's some things that we need to know. You can't skip stem numbers. And you'll see what I mean by that in a second. You must have a key. This is a big thing people will always forget, and then I have to take points off. But you have to have a key so people know how to read your stem and leaf. And then the next thing is only one number in leaf. Okay? So we're going to do a stem and leaf for the same data here. So we have our stem, and we have our leaf. You do not have to write the title stem and leaf when you make this, but for now I'm going to write it so that you kind of know what's going on. Okay, so what I have is I have our list of data from the states. I just have it on Excel so I can easily see it. So my stem has to kind of include, it's the first number. And so for my stem, I'm going to have a 0, and then a 1, and then a 2, 3, 4, and 5. And what those are the tens digit. And sometimes you could do hundreds digit. There's other things you could do, but this is what we have. So anything that fits in this first bin, 0 to 9, goes here. And so a lot of times when you have a list, you're just going to do, so 15 is a 1 and then a 5. The second number here, 22, is a 2 and then a 2 here. 3 is the number 03, so I put the 3 here. 2 is right here. So what's nice about a stem and leaf is the leaves don't have to be in order. As long as they are on the right line, that's all that matters. I got another 22, a 10, a 16, a 5. And so you kind of get the point. And so I'm just going through and I'm filling this in. This second one's going to have 15 numbers. So there is a strategy I'll show you later that you could do to make it a little easier. But if you have if you want to make it shorter left to right, that means it's going to be longer up and down. Okay, 16, 4, 12, 7, 16, 3, 13. I'm going to have to scroll that over some. Let's see if I can do that. There we go. 18. Oh, we got a 20. Not many there, though. You notice, you know that we're not going to have anything in 3s and 4s, but this is what I mean by you can't skip stems. You cannot go 0, 1, 2, and then 5. You have to have all of them, okay? Here's the 50 way down here, and then I'm just going to keep going. I'm almost done. And then a 19. Oops, I didn't mean to write a 1. A 19, and then a 13. Now, I can't physically turn this paper sideways, but after you write it down, if you turn your notebook sideways, it's going to be the exact same shape as that histogram. Do you see how it has a medium-sized bin, a tall bin, a small bin, and then a much smaller bin? That's what this has here. A stem and leaf graph is a histogram turned. Okay, and there's benefits for more. Like if you're doing a report, you're not going to have a fancy report with a stem and leaf plot. You're going to have a histogram. Oops. Oh, hold on. Okay. And so again, we're going to learn how to describe histograms and stem and leaf, but for now, we're just learning how to make them. And again, something else to remember, these numbers don't have to be in order, but I have to have a stem and then a leaf, okay? To make the key, what you do is you pick a number. So I'm going to pick the number 15, and it equals 1/5. Okay? And so that tells me 1 is in the stem, 5 is in the leaf. When we get to bigger problems, you might have the number 205. And the ways you could do this is you could say 20 is the stem and 5's the leaf. But you know what that's going to do? That's going to make you have 20 numbers, which is huge. A lot of times what we're going to do is we're going to say 2 is the stem, 0 is the leaf, and we're just going to ignore the 5. Or you can round up and make it a 1. But if we do something that has 20, that means we're going to have to start at 0 or whatever the smallest number is and go really big. And so that's a lot. So a lot of times when we have bigger numbers, we're going to do this. The other thing that we're going to do, sometimes if you have decimals, I know I'm kind of writing examples everywhere, but not in class, so I have to figure out how to show you this. If I have 12.6, you could do it 2 ways. You could do 12 with a 6 as a key, or you could do 1 with 3. And that shows me that I've made the 6 rounded up to a 3, and then I just kept it this way, 1 with 3. Okay? We will do some of these in class to practice, but you have to make sure if you have questions that you're asking me, because it can be a little tricky. Okay, last one we have is dot plot. This one does not have bins. And this one's usually, this is the most basic thing to go to. It's good for small numbers. And your numbers are in ranges. And so I'm not going to really do it for our states because that's not a small number, right? Let's say I asked you how many, or we looked at the brother-sister question. How many siblings do you have? And so if you wrote that you had 0 siblings, in class we would do a lot of dot plots. I would have you go put your dot on the piece of paper or on the board. You have 0 siblings, so you put there. A couple people have 1 sibling. A couple people have 2 siblings. Not as many have 3. Nobody has 4, but somebody has 5. That's a dot plot. Dot plot works for small numbers. It still shows the shape of a graph, but you just have to put dots there. You would never, though, come and do this. You would never say, oh, that's too tall, I'm going to put a dot here. It does not work like that. You cannot do that. You have to make sure that you continue doing vertical. Okay? All right, so these are the 3 main types of graphs. There will be another type of display we learn in another video, but this one is just dealing with histograms, stem and leaf plot, and dot plot.